This is Geometry, Chapter 2, Section 4, in which we will learn more about deductive reasoning. We've already talked about inductive reasoning, how that relates to finding a pattern and then making a conjecture based on what you've observed in the past, what you expect to happen in the future. Deductive reasoning, on the other hand, is using facts, rules, definitions, or properties to reach conclusions from given information. So you're using general things that you know to make specific conclusions. And that's the big distinction between the two. Inductive reasoning involves going from specific cases to make a general rule. We've had a quiz every Monday in government, so I expect there to be another quiz next Monday. You're looking at the specific cases of every Monday it has happened, so you think it will continue to happen. That's inductive. Deductive is going from a general rule to the specific case. Saying something like, the first team to 25 wins. We were the first team to 25, so we win. The first team to 25 wins is a general rule for, in this case, volleyball. The specific case is we were the first one to get to 25, so we win. We're applying the general rule to the specific situation of this one. That's deductive. Inductive is expanding out to general rules. Deductive is bringing the rules down to specific cases. So they're going to ask us to decide which kind of reasoning they're using to be able to make statements. If we know that all of the signature items on the restaurant's menu have a special symbol beside it, say it's a heart or a diamond or a star or some such. It's their signature items that they think they make better than anyone else. And those are marked with a special symbol. Kevin orders a menu item that has that symbol next to it, so he's decided what he has as a signature item. The question is whether this is inductive or deductive. He's going from the general rule that all of the signature items have a special symbol. That's the overall rule. Then he's getting specific. This thing that I ordered has the special symbol, so it must be a signature item. He's going from the general rule to the specific case. So that's deductive. Take a look at the second one. Every time Katie has worn her lucky socks to her softball game, she's gotten a hit. She's wearing her lucky socks today, so she concludes she will get a hit. Okay. She's going from specific cases in the past. Every time she's worn her socks, things have worked out the way she wanted to. That's been the specific cases in the past, and she's then expanding it to say, well, every time I wear my socks, I'm going to get a hit. So that is inductive. She's going from specific cases in the past to the general rule that means she gets a hit every time, or every game. When we're working with deductive reasoning, there's two basic rules. They call them valid forms. There's two basic rules that you can use. The first one is called the law of detachment. And all that the law of detachment says is when the hypothesis of a statement is true, then the conclusion must also be true. So they're saying remember when we talked about the conditional statements, the if and the then? When the if part, the hypothesis, is true, then the conclusion will also be true, based on the law of detachment. So, for example, if a person has a ticket to the game, then he may enter the stadium. That's a conditional statement. Our hypothesis is the person has a ticket to the game. The conclusion then would be he may enter the stadium. And Brian happens to have a ticket to the game. So by the law of detachment, since he has met the qualifications of the hypothesis, then Brian may enter the stadium. The hypothesis was in fact true. Brian does have a ticket to the game. So then the conclusion must also be true. Brian may enter the stadium. That's the law of detachment. The second one is called the law of syllogism. Okay. When the conclusion of one conditional statement matches the hypothesis of the next, then effectively you can skip that part of the discussion and just make yourself a new conditional. For example, consider these two statements. If you get a job, then you will earn money. If you earn money, then you will buy a car. The conclusion of the first statement, you will earn money, is the hypothesis of the next statement. So we can cut out the middleman, as it were. We can go straight to, if you get a job, then you will buy a car. Okay? Because the two statements here, the hypothesis in one, match the conclusion of the other. We can skip that and just go straight to a new conditional statement. That's the law of syllogism. Okay. Now, it's important to know here, when we're talking about the law of syllogism, if the conclusion of one statement doesn't match the hypothesis of the next, then you can't make a conclusion from it. Suppose this had said, if you get a job, then you will earn money. If you have a driver's license, then you can buy a car. Well, having a driver's license doesn't match earning money. So that would not be something I could use the law of syllogism on. Conclusion from one statement has to match the hypothesis of the next, or you can't do anything with it. So we're going to be drawing some conclusions and then stating which form we used, whether we used the law of detachment or whether we used the law of syllogism. Okay. The midpoint divides a segment into two congruent segments. And then if two segments are congruent, then their measures are equal. And then they tell me specifically that M is the midpoint of segment AB. So we have a lot going on here. Midpoint divides a segment into two congruent segments. We could write that as a conditional statement. If a point is the midpoint, then it divides a segment into two congruent segments. Okay. If two segments are congruent, then their measures are equal. That sounds a lot like syllogism. We have a hypothesis here of two congruent segments. We had a conclusion involving two congruent segments. So that fits the law of syllogism. Now we know that M is the midpoint of AB, so that means AM is equal to MB by the law of syllogism. Consider this last example here. If you are 16 years old, you may apply for a driver's license. Bill is 16 years old. Okay, this is kind of a giveaway. There's not two conditional statements, so it can't be the law of syllogism. You have to have two statements or more for syllogism to happen. If you are 16 years old, you may apply for a driver's license. Bill is 16 years old. He has met the requirements in the hypothesis, so now he gets the benefit of the conclusion, and that conclusion is that he may indeed apply for a driver's license because of the law of detachment. Okay. It had to be law of detachment because we didn't have two conditional statements. So deductive reasoning, we're going from general rules to specific examples and applying what the general rule says to the specific case. It could be through syllogism, where you have multiple conditionals to combine together, or it can be through the law of detachment, where you have one conditional and you've met the criteria that the conditional set forward, the hypothesis set forward. And as always, if you had questions along the way, I hope you wrote those down. Bring them in with you, and we will see you in class.